Good morning. My name is Robert Ramdhan, and this presentation is for CEN6405 Computer Performance Modeling, and my paper is Reducing Feature Set Explosion to Facilitate Real-World Review Spam Detection. The authors of this paper is Michael Crawford, our professor, Dr. Kashkofter, and Joseph D. Prusa. On to the next slide, our outline is our introduction and show the related works, our empirical design, our results, and our conclusion. On to the next slide. So our introduction shows that the consumers have looked at review or recommendations online for certain products and services before they are bought. There are spammers and fake reviews that have left untruthful and fake reviews on these products and services. There are methods for detecting fake reviews, since untruthful reviews can damage consumer trust and negatively affect their purchasing habits. The research on detecting review spam involves training classifiers, which is using a labeled data set, and they are applying it to determine if it is fake or not. The question comes from how many of the word features are needed to effectively train a review spam classifier? But this question has been ignored. On to the next slide. A feature shows the evaluation of effectiveness of two methods after feature selection for reducing the feature set size in review spam detection. The researchers will compare the feature selections using word frequency versus a chi-squared feature selection method across the different classifiers. The data set used in the study covers restaurants, hotels, and doctors. These are the three domains. The lower the feature subset sizes, the chi-squared feature selection technique performed better using word frequency for all of the classifiers. The higher the feature subset sizes, there were no differences between these methods. Now to the related works. The field of the online review spam detection is still considered new. All reviews which are duplicates or near duplicates are considered spam. The researchers trained a logistic regression classifier on the data to identify spam which are not duplicate reviews. The manual analysis of 100 of the non-duplicate reviews which had been classified as spam. 52 of these 100 were actually spam. In a recent study by Lee et al., a dataset was modified to include two more domains, which are restaurants and doctors. The Amazon Mechanical Turk (AMT) is used to collect fake reviews. A different study showed that the reviews created via AMT were easily identified than reviews which have been flagged as spam on websites such as Yelp. In a study, Lee et al. Used a dataset to include extra domains, and he solicited fake reviews from actual employees and classified them as expert reviews, because the information will be more accurate. The authors cite the effectiveness of training and evaluating an SVM classifier on each domain, which then the researchers observed the unigram features had the best performance. It was not clear how many features were used or how they were selected. An insight from Lee et al. Study was able to tell apart truthful and AMT reviews then truthful and expert reviews. Now on to empirical design. In this study, the dataset from Lee et al. Is used, which has three domains of restaurants, hotels, and doctors. The truthful reviews were collected from actual review websites, while the fake were obtained from AMT and industry experts. The breakdown of the dataset is below. So as you can see in the table, our domains is doctors, hotels, and restaurants, which are then a value is there for the truthful reviews, the spam reviews, and the total of the two. And we can see how our data is distributed with the classes and the domains. There are 5 different classifiers. The decision tree, which is C4.5. The logistic regression is L3. The naive-Bayes is NB. The multinomial naive-Bayes is MNB. And support vector machines is SVM. The classifiers were implemented using the Weka tool, using the default values and complexity constant C is equal to 5, and build logistic models is set to true in Weka. For 4 runs, which are of 5-fold cross-validation, which were used in the experiments, which helped reduce the chance of bias due to good or bad data splits. Performance is checked using the area under the receiving operating characteristic curve, AUC. The curve is a graph where the false positive rate on the x-axis versus true positive rate on the y-axis. By determining the area under the curve, the researcher can estimate the true predictive ability of the model. With word frequency, 10 filter-based feature selection techniques were used for the study. Signal to noise, S2N, chi-squared, which is CS, multi-information, MI, area under the precision recall curve, PRC, area under the curve, AUC, Wilcoxon rank sum, WRS, and probability ratio, which is PR, and Gini index is GI. As you can see the table below, it shows our 10 techniques. The groups are classified in, which is Group A, Group B, Group C, Group D, Group E, the area under the curve for each of those techniques, and the standard deviation for each of those techniques. Now, the filter-based techniques are used in favor of wrapper-based techniques since they are less complex. This experiment was done to evaluate each of the 10 filter-based feature selection techniques against the combined data set with the classifiers. The number of features varied from 10 to 1,000 in increments of 100 for each combination of classifier and feature selection technique. The Tukey's HSD test was ran and shows that S2N and CS are in the top group A. AUC, KS, MI, and PRC are in group B, and SAM in group C, WRS in group D, GI and PR are classified in group E. The researchers chose CS for the study since it's commonly used and there is not much of a difference in the feature selection choices found in group A from the table we saw in the previous slide. Onto our results slide. So the experiments were done to analyze each classification technique across a range of subset sizes. The researchers attempt to determine how many features are needed for the different classifiers in the review spam domain. For example, C4.5 and Naybanes have feature subset sizes from 100 to 5,000, as the performance does not change. The remaining classifiers were evaluated from 100 to 10,000 as they had higher subset sizes. As we can see in the picture on the right, we can see our filters that were mentioned before and how the table describes it. This is the comparison of feature selection techniques across classifiers. Now we will see the ANOVA table on this slide, which shows that the classifier feature selection techniques and the subset sizes are significant. If we look below, for the 4.5 decision tree, the chi-squared feature selector has a higher area under the curve than frequency for subset sizes. The chi-squared should be used in favor of frequency for this classifier and domain, as we can see in the graph on the right. Now for logistic regression, using frequency is good at very high number of attributes, and a feature set of this size is not good. A logistic regression classifier is very unstable with respect to feature subset size on this dataset, which is shown on the right with our logistic regression. How it says the average AUC score for logistic regression using feature subset sizes from 100 to 10,000. If you look at the bottom, we see our Naybanes, which is using the same subset size from 100 to 10,000, and it says for Naybanes that the lower feature subset size is less than 1,000. The chi-squared feature selection has a higher area under the curve than frequency. The choice in feature selection is dependent on feature subset size. On this slide, we have our support vector machines, which is SVM, and for this, the average AUC for frequency shows an increase with additional features, but it never reaches the peak obtained by chi-squared feature at 400 features. With the SVM, chi-squared should be used when smaller feature subsets are needed. For the multinomial Naybanes, for the graphs on the right side, this provides the best performance for the dataset. For smaller subset sizes, chi-squared performs better. If a larger subset is chosen, there is no gain. On this slide, the Tukey HSD test was performed comparing the AUC scores of each classifier when using chi-squared feature selection. Multinomial Naybanes and SVM being the best classifiers, and logistic regression and C4.5 are worse than the others. Normal Naybanes fall in the middle, and the HSD test takes into consideration the subset size as a factor and does not group them together by it. As we can see below, our graph shows how they're labeled. Now, as we conclude, we see that as the number of review sites grow, the feature sets can grow beyond what can be handled by traditional machine learning techniques. The method is to select the words which appear the most or use filter-based feature rankers to rank features and then select the top features. The main finding of the study is that there isn't a one-size-fits-all approach that is better than the rest. When discussed, the work in the future, according to the researchers, should include determining if the domain of the user reviews has any effect on the results. On this last slide, this is my references, and thank you.